Next chapter, Arithmetic Progression. In this chapter, we are going to study about sequences, definition of arithmetic progression, nth term of AP, sum of n terms of AP, arithmetic mean, and some other questions on AP. First, you should know what is sequence. A set of numbers occurring in definite order following a rule is called a sequence. There are two parts in this definition. First, set of number, a group of numbers occurring in a particular order. There is importance of order in sequence, and whatever numbers are written, they follow a particular rule. For example, 1, 4, 7, 10. In definite order these numbers written. Now rule, just easily you can think. If you are able to identify the rule, easily you can find next number. 1 plus 3, 4. 4 plus 3, 7. 7 plus 3, 10. 10 plus 3, 13. It implies next number will be 13. It implies these numbers written under a definite order and follow a rule. And what is rule? That is defined here. Same pattern. Next some numbers written. Now first you try to identify the rule under which these numbers written. 2, 1, 1 by 2, 1 by 4, 1 by 8. Just to observe carefully, you can observe here. Every number is half of its previous number. First number 2. Divide by 2, you will get 1. 1 divided by 2, 1 by 2. 1 by 2 divided by 2, 1 by 4. Then 1 by 8. Next number will be 1 by 16. Same process, third example. 1, 1 by 2, 1 by 3, 1 by 4 written. What is written here? Pattern here. First number we can write 1 as 1 upon 1. The numerator in every fraction is 1 and denominator increased by 1. Here denominator is 1, then 2, then 3, then 4. It implies next number will be 1 upon 5. We see it. It's also a follow by particular pattern. Now fourth example. 4, then 5, then minus 4, 3, 2. Just think what is pattern here and what is the next number. Can you guess? First you think, I am telling you next example till now. 3, 9, 27. Here again easily you can identify the pattern. 3, 3, 3 are 9, 9, 3 are 27. And then next number 27, 3 are 81. Again easily you can identify the pattern. Here 16, 12, 8, 16 minus 4, 12, 12 minus 4, 8, and same pattern is continuing. 8 minus 4, 4, then 0, then minus 4, minus 8. This thing. I have discussed each and every part, but in fourth part, I hope you all are thinking what is pattern here. Basically in fourth part there is no pattern. At random some numbers I have written. And if group of numbers which does not follow any particular rule, then it is not a sequence. It implies here all are sequence except fourth part. Fourth is not a sequence. Now next, there are two types of sequence, finite and infinite. Finite sequence, if number of terms in the sequence finite, it is called finite sequence. For example, 1, 4, 7, 10, 25. It implies here last time is 25. Up to 25 you have to write. means the here number of terms is not infinite, is finite sequence. Same pattern here. First, second, third, and last term is also given. If last term is given, then it is known as finite sequence, or there are finite number of terms. Infinite sequence. If number of terms in the sequence is infinite, it is called infinite sequence. 2, 4, 6, 8. It is a sequence, but here, what is the last term? We can't find. There are infinite number of terms, therefore it is known as infinite sequence. Same pattern. Second, 2, 1, 1 by 2, 1 by 4. It is also infinite sequence. Then next, progression. A sequence following definite pattern is called progression. In progression, generally what different pattern you are going to search? If every number you are getting by addition, subtraction, multiplication, or division by a constant number in previous number, then it is known as progression. 1, 4, 7, 10. You are getting next number by addition of 3. Here, by dividing, you are getting next number. It implies a sequence is known as progression if it's follow a definite pattern. And what is definite pattern? Means between two consecutive terms, a rule is there, and rule by is for addition, subtraction, multiplication, or division. Types of progression. One is arithmetic progression, geometric progression, and third one is harmonic progression. If next term in the sequence you are getting by addition of a constant number, then you can say it is in arithmetic progression. Or by subtraction you are getting, again it is in APR, arithmetic progression. If next term you are getting after multiplication or division by a constant number, then that progression is known as geometric progression. If arithmetic progression numbers given 1, 4, 7, 10, reciprocal of these numbers known as in harmonic progression. If 1, 4, 7, 10 are in arithmetic progression, then 1 upon 1, 1 upon 4, 1 upon 7 or 1 upon 10 known as in harmonic progression. Now here, as per your syllabus, in this video, I am going to cover only one topic, arithmetic progression. Arithmetic progression means a sequence in which each term except the first term differ from its preceding term by a fixed or constant number is called arithmetic progression. And that fixed number is called common difference, denoted by D. It implies if terms are A1, A2, A3, A4 in the arithmetic progression, A1 means first term, A2 second term, AN nth term. Then common difference we can write as A2 minus A1, second term minus first term, or A3 minus A2, or A4 minus A3, or AN minus 1. Again, just a sequence in which each term except first one differ from its preceding term by a fixed number, that is D. Is called in arithmetic progression. This common the difference which is common, A2 minus A1 is same as A3 minus A2, is same as A4 minus A3. This difference is common, therefore it is known as common difference. It may be positive, negative, or 0. Just in this example after this, first term value of A1 is 1, A2 equal to 3, A3 equal to 5, A4 equal to 7. Here common difference a2 minus a1. What is the value of a2 minus a1? 3 minus 1 equal to 2. Now a3 minus a2, again 2. a4 minus a3, again 2. Whatever difference between two consecutive numbers given, it is common. You take any two consecutive number, this difference is common. Therefore, this word is used, common difference. Its value is positive, negative, or 0. Positive means you are getting here 2 plus 2, you are getting next number is increased. If common difference is negative, then number will be decreased, and if common difference is 0, there is no change in the number. The first term, symbol for first term is also only a or a1. Now next, nth term of AP. Nth term of AP with first term a and common difference d is given by an equal to a plus n minus 1 into d. Proof of this identity: if first term of AP is a and common difference d, then a1 we can write as a, but first term symbol is both the same symbol, equal to a plus 0 into d. Because there is no term of d, it implies coefficient of d is 0. a2 equal to first term plus common difference d, because a2 minus a1 equal to d means a2 equal to a1 plus d, equal to a plus 1d equal to a plus 2 minus 1 into d. Why I have written in terms of 2 minus 1? Because position is second term. Second term we are writing as 2 minus 1 into d as coefficient of d. a3, a2 plus d, and value of a2 is a plus 1d, plus d means a plus 2d, write down 2 as 3 minus 1. Similarly, if you observe, a3 written as a plus 3 minus 1 into d, a2 written as a plus 2 minus 1 into d. Therefore, an equal to a plus n minus 1 into d. Coefficient of d is 1 less than position of term. Therefore, nth term of AP equal to a plus n minus 1 into d. If an is the last term of AP, then an equal to L equal to a plus n minus 1 into d. Sum of n terms of AP, next identity, which is given by Sn equal to n by 2 bracket 2a plus n minus 1 into d. Since first term of AP is a and common difference d, therefore a1 equal to a, second term a plus d, third term a plus 2d, and nth term is a plus n minus 1 into d. Therefore Sn we can write as Sn equal to first term a plus second term a plus d plus dot dot n minus 1 term, then nth term. Again write down Sn, but start from last term. Last term written as first a plus n minus 1 into d plus a plus n minus 2 into d dot dot and a plus d plus a. Sn 2 times written, but in RHS order is changed. First time written is starting from first term and second time written is starting from last term. If add these two, Sn plus Sn, then check RHS. a plus n minus 1 into d plus addition of second term of both written here plus dot dot addition of second last term is here and addition of last term is written here. If you observe carefully, here open the bracket, a plus n minus 1 into d, duplicate a plus a means 2a plus n minus 1 into d. Means next we can write Sn plus Sn as 2Sn in bracket 2a plus n minus 1 into d plus second bracket again after simplify you will get 2a plus n minus 1 into d. Here again 2a plus n minus 1 into d, and last time is again 2a plus n minus 1 into D. Each and every term value is same. And how many terms are there? N terms. Because Sn means sum of n terms. Therefore, if any number repeated as n times, multiply by n. We can write 2Sn equal to n into 2a plus n minus 1 into d, or Sn equal to n by 2 2a plus n minus 1 into d. And that is the formula to find sum of n terms of an AP. Then next, Sn also we can write as n by 2 2a plus n minus 1 into d. 2a write down a plus a. Here a plus n minus 1 into d is the formula for nth term. It implies Sn we can write as n by 2 in bracket a plus an. Here a, and this is the formula for an. The first formula for Sn is n by 2 2a plus n minus 1 into d. Or also we can write sum of n terms is n by 2 a plus an. N means nth term. Or also if an or nth term is the last term of AP, then already we have covered an equal to L equal to a plus n minus 1 into d, means in place of n write down as L here. Then next, nth term of AP from int. If first term of AP is a and common difference d, and last term is L, then AP is given by a first term, a plus d, a plus 2d, and last term as L. L we can write as an or a plus n minus 1 into d. Second last term, L minus d. Then last term is written as L. Second last term means second term from int L minus d, or which is L minus 2 minus 1 into d. Third term from int L minus 2d, which is equal to L minus 3 minus 1 into d. Or result we can write nth term from int equal to L minus n minus 1 into d. And that's the formula by which we can find nth term from int of an AP. That is L minus n minus 1 into d. Now next, arithmetic mean. If three numbers are in AP, 2, 4, 6, 2, 4, 6, three numbers are in AP, then middle number is known as arithmetic mean between the other two numbers. If three numbers given as 2, 4, 6, then 4 is known as arithmetic mean of 2 and 6. If 8, 10, 12 are in AP, then 10 is known as arithmetic mean of 8 and 12. If ABC are in AP, then B is called arithmetic mean of between A and C. It implies if ABC are in AP, then common difference is same, is B minus A equal to C minus B, or 2B equal to A plus C, or B equal to A plus C by 2. Means final formula we can write as arithmetic mean equal to sum of numbers upon 2. If by chance value of B is not given, A and C given, if find arithmetic mean of A and C, easily you can write third number A plus C by 2. If 4 and 6 given, you find arithmetic mean of 4 and 6, so simply you can write 4 plus 6 by 2, 10 by 2, that is equal to 5. 5 is arithmetic mean between 4 and 6. It implies 4, 5 and 6 for my AP. Now next important part, if sum of n term is given, you have to find the nth term. Then the process by which we can find the nth term. First term symbol A, common difference D. Formula for Sn already covered, n by 2 bracket 2a plus n minus 1 into d. Step first, find out S1, sum of one term. Sum of one term is same as first term. In place after write down 1 by 2 in bracket 2a plus 1 minus 1 into t equal to 1 by 2 into 2a equal to t. Yes, 2 sum of first two terms of AP. Putting formula 2 by 2 in bracket 2a plus 2 minus 1 into t equal to 2a plus t. Similarly, sum of three terms of AP 3a plus 3d after solving. Sum of four terms of AP again 4 by 2 in bracket 2a plus 4 minus 1 into t. 4 by 2 means 2 in bracket 2a plus 3d, open the bracket 4a plus 6d, and so on. In this pattern, if Sn given, then first you find out S1, S2, S3, S4, and so on. Then S1 is same as A first term. If any AP is given 2, 4, 6, 8, the sum of one term or first term both is same. Then S2 minus S1. S2 is given as 2a plus d minus a. The 2a minus a means a. That is a plus d, and a plus d is the second term. The second term of a is a plus d. S2 minus S1 after solving we are getting second term equivalent to second term. S3 minus S2 just put and solve. After solving we are getting a plus 2d which is equal to a3. S4 minus S3 equal to a4. It implies, if anyone asks, S9 minus S8 equal to A9, or S5 minus S4 equal to A4. Or similarly, you can write Sn minus 1 equal to An or nth term. Whenever sum of n terms given, you can follow all the steps, or directly you can write nth term of AP equal to sum of n terms minus sum of n minus 1 terms. Using this formula, you can find nth term of AP whenever sum of n terms is given. Sum of first n natural numbers. Natural numbers are 1, 2, 3, 4, 5. Here first term is 1 and common difference 2 minus 1 equal to 1. Therefore, sum of n terms we can write as n by 2, 2a plus n minus 1 into d. Put the value of a as 1 and d 1. Simplify 2 into 1, 2 plus n minus 1 equal to n into n plus 1 by 2. It implies sum of first n natural number equal to n into n plus 1 by 2. If anyone asks find the sum of first 5 natural number, you can write 5 into 5 plus 1 means 6. 5 into 6 by 2 means 30 by 2, 15. Sum of first 10 natural number, 10 into 11 by 2 equal to 55. In this pattern, you can find sum of first n natural number. Now next, sum of first n odd numbers. 1, 3, 5, 7, 9 odd numbers given. Here first term is 1 and common difference 3 minus 1. Sum of n terms formula is n by 2 in bracket 2a plus n minus 1. Put the value of a and d. 2 into 1, 2 plus 2n minus 2. n by 2 equal to 2n equal to n square. It implies sum of first n odd natural numbers equal to n square. N equal to n square. Sum of first three odd numbers means 1 plus 3 plus 5 equal to, directly we can write as 3 square. There are 3 terms. Also you can verify here. 1 plus 3, 4 plus 5, 9. Sum of first 4 odd numbers. Sum of first 4 odd numbers means 4 square 16. You can verify it. 1 plus 3, 4 plus 5, 9 plus 7, 16. In this pattern, you can find sum of first n odd natural numbers. If even numbers given 2, 4, 6, 10, then first term is 2 and common difference 4 minus 2. Then Sn equal to n by 2 in bracket 2a plus n minus 1 into t. Value of a right as 2 and d2. Simplify. After summing you are getting n into n plus. It implies sum of first n even numbers equal to n into n plus 1. Sum of first 3 even numbers 3 into 4 12. You can verify it. 6 plus 4 10 plus 2 12. Sum of first 4 even numbers 4 into 5 20, and also can verify it. 8 plus 6 14 plus 4 18 plus 2 20. In this pattern you can find sum of first and even numbers. These are the basics of this chapter, arithmetic progression, which you have to prepare. And now questions for practice. First question, find 10th term from int of an AP. AP is given, you have to find 10th term from int. This formula you know, that is L equal to 10th term from int L minus n minus 1 into t. If the 7th and 13th term of AP given, find the AP. Third question, you have to find first negative term of AP. In fourth question, Sn is given n square plus n, you have to find nth term. Fifth question, you have to find number of terms such that their sum is 120. And last in question number 6, find the sum of first 40 positive integers divided by 6. These 6 questions you have to complete and submit your